All right. So good morning. My name is Tuan Amith. I'm an assistant professor over at the University of Texas Medical Branch. So on behalf of my co-authors, I'll be sharing some preliminary effort and using a different type of NLP method, namely open information extraction for the purpose of enrichment and evolvement of biomedical ontologies. And just to foreshadow, I'll briefly talk about vaccines and the target ontology that we are using as a use case, namely the vaccine ontology. So I'll briefly discuss some ontology about what is ontology evolution, and I'll also give some details about open information extraction. And then I'll segue into our work in using open information extraction and discuss the initial results. And finally, I'll reveal our future direction to scale up this work. So since the 18th century, vaccines have helped mitigate human mortality and diseases. Currently, there are 63 vaccines that are approved for use in both animals and humans, and they are delivered either through oral or through syringe or nasal spray. And because of their major impact and importance in the biomedical domain, there is an OBO-foundry ontology for vaccines, namely the Vaccine Ontology, which is a community-agreed domain computable representation of scientific knowledge surrounding vaccines. And it has about 6,947 classes and 233 properties, according to the current release of it. And the Vaccine Ontology has been demonstrated in various literature mining studies and also data integration studies, which is beyond the scope of this presentation. As one author has put it, change is inevitable. So principally in the context of ontologies, you're going to be encoding new knowledge and adapting it to your knowledge base. But just to formalize, ontology evolution is the process of adaptation of ontology to arisen changes in the corresponding domain, while maintaining both the consistency of the ontology itself as well as consistency of depending artifacts. So with the exponential growth of scientific literature and data resources, expanding and further extending the coverage is important for a lifespan of an ontology, which kind of leads us to a couple of needs, which is a need to rapidly expand the terminological domain space and also to ensure the knowledge is consistent with new emerging knowledge. So to address this challenge, we investigate the use of natural language processing-based methods, specifically open information extraction, to assess its applicability to assist in the enrichment and alignment of new knowledge from scientific resources. So open information extraction is a paradigm for automatically extracting relations from a massive heterogeneous corpus in natural language without requiring any predefined schemas. So the primary objective of open information extraction is to convert unstructured text into structured information that resembles an ontology format, basically a triple. So a subject, predicate, object, which is kind of the building blocks of an ontology. So open information extraction has been applied in various domains and applications. For example, question and answering, automatic knowledge-based construction, information retrieval, and ontology alignment and mapping. So just to give you an example, of what the output for an open information extraction might look like, we can, so if we have like a statement to process, like the statement, the human papillomavirus, HPV, leads to cervical cancer, we can extract the triple of a set of like human papillomavirus, which is a subject, leads to, which is a relation, and cervical cancer, which is an object. Some open information extraction could also extract implied triples. So like the second example would be like human papillomavirus, which is a subject, which is a relation, and HPV, which is like the object. So basically could extract these two types of triples from that statement in the example. And so basically, just to go over some basic OIE approaches, there are essentially like four different types of open information extraction methods. So I'll go over some of the basic ones just to just for introduction. Um, so a team of researchers from Microsoft proposed the initial concept of rule-based open information extraction. So in rule-based open information extraction, rules or patterns are developed to recognize and extract relationships between entities in a sentence or text. So in rule-based open information extraction, the extraction rules or patterns are designed to identify and extract relationships between the entities from the sentence or text. So, one advantage, for what it's worth, rule-based open information extraction allows for the application of handcrafted extraction rules, providing the advantage of tailoring the system to specific linguistic patterns and improving the accuracy and quality of extraction. So furthermore, rule-based open information extraction can, leverage language agnostic patterns and a universal dependency parser, enabling the system to work across multiple languages. However, these rules may also limit the system's coverage of extraction results by, being constrained to linguistic variations and syntactic constructions. So another OIE approach is pattern-based open information extraction, which is based on predefined linguistic patterns. So pattern-based open information extraction extracts relational triples from structured text. So for example, using like a predefined set of parts of speech patterns to extract verbal relation sequences. And then there's some dependency-based open information extraction relationships, leveraging like syntactic dependencies between a word and a sentence. So by examining the syntactic connections among words within a sentence, dependency-based open information extraction analyzes the grammatical relationships to extract relations between entities. And then finally, clause-based open information extraction segments sentences into their individual clauses and subsequent extraction relations from each of these clauses. So the clause extraction steps can include dependency parsing, clause type analysis, and generating propositions. Clause-based open information extraction offers the advantage of considering all adverbials within a clause, which could result in like comparable or even higher precision recall by extracting greater number of like statements compared to other open information extraction methods. So the rationale of using open information extraction for this study is that the extracted information is provided in a subject relation object format, and essentially the subject and object of the extracted information would yield some identified entities from formalized textual sources. At least specifically in our case, we'll be using PubMed literature. And these entities could be examined and integrated into community-generated biomedical ontologies and knowledge graphs. In addition, the relational data that links the entities, like the subject and object, could also be examined and integrated into existing ontologies. And another benefit for open information extraction is that some methods could also produce, like an example I showed, implicit relationships that may not be easily captured in other methods. So we surmise that open information extraction can extract relevant and novel terms, entities, and relations that can, expand a biomedical ontology's terminological and domain scope. And we will use the vaccine ontology as our candidate target for our work. So we'll investigate whether open information extraction can discover potential new classes for the vaccine ontology, and whether open information extraction can discover new object properties or relations for the vaccine ontology. So for our preliminary review, we focused on ClausIE, which is a clause-based open information extraction method, Standford Core open information extraction, and MinIE, which is kind of an offshoot of ClausIE. So for each of these OIE methods, we use the default configuration. The extraction analysis software code was developed using Java 11, using a variety of like API libraries like OWL API, Google Gaba, Symmetric, that does like string similarity, which I'll discuss later. JSON, JDBC, PostgreSQL, and also JSoup to do some XML parsing of the PubMed literature. And so we downloaded the available full text of PubMed central articles on June 2023 and extracted the abstracts from each of the articles using like the aforementioned JSoup API library. And we stored the abstracts in a PostgreSQL database that amounted to about 950,000 articles. And from the database, we filtered the abstracts based on the term occurrence of vaccine, which was about like 12,126. And however, as we explain later, we used only like a small sample for this small study of 20 of abstract because, it's just a preliminary review. And we stored the terms and we compared it with the terms from the vaccine ontology. So just to further explain that, we use the stored terms, the entities, which is the subject and object, and the object properties and the relations, and compared it with the terms from the vaccine ontology. So entities were compared with the vaccine. The entities like the subject and object were compared with the VO's classes, and the relation terms were compared with the object properties of VO. So we just for this use case, we used the basic cosine similarity metric, string similarity metric that compare the characters between the two sets of tokens. So basically, a cosine similarity of 1 would indicate that there's an between the extracted PubMed term actually exists in the VO. So we kind of ignored that because since that term has already been incorporated. However, if the metric results had like a rating of 0.6, 0.60 or above, we record it as a potential candidate for the vaccine ontology. In addition, we also identified a set of entities and relations that had both 0.60 or above. For example, if we had an extracted triple, subject, predicate, object, and if one of the entities, either the subject or object, is 0.60 or above, and the relation is also 0.60 above, we recorded that both the entity and the relation. So for the 20 abstracts, we analyzed 3,427 sets of triples, which is kind of an aggregated extraction results from all three of the methods that we looked at. So from our examination of the NLP methods applied on the 20 PubMed central abstracts, we revealed up to about 233 to 287 entities as possible candidates for possible inclusion into VO, and 33 to 40 relational terms. So from an initial review, there were a few entities that may be potential terms for inclusion into the vaccine ontologies vocabulary. So for example, this would include like the rotavirus co-infection term, also cell vaccine, vaccine acceptance, vaccine confidence, activated T cells, single dose, second dose, and so on. So there's some more as well. As far as like relational terms, they presented some potential relations for inclusion as well. However, most of the relation terms are semantically similar to existing relations in the relation ontology, which is an ontology that the vaccine ontology leverages. So the relation ontology, for those who don't know, has very complex and semantically nuanced object properties. And so a simple relational term like cause has numerous nuanced and various causal relationships. So about like 189 types of causal relationships. So there are varying degrees of it. So however, there are some relational terms that could be considered, like boosted, positioning, or obtained after vaccination may be possible object properties for inclusion. So for this early work, we have possible directions in the future. We limited ourselves to a sample to test our objective. So with ample time and resources, we foresee being able to extract a larger set of terms to maybe assist in the expansion of the vaccine ontology using existing scientific literature. So in addition, with our work, we could replicate and automate the process further using the software resources that we developed. Our extracted terms originated from abstracts and not from the full text. However, we assume that we can gather additional terms using the full text of the PubMed articles, and we may investigate the likelihood of using, say, like full text in the future. And while we extracted potential terms for entities and terms, there is a need to vet and align them to the vaccine ontology. So we propose in the future enlisting experts who are familiar with VO to review our extracted terms for a potential addition to the VO's terminology scope. And also our approach was limited by 3 of the state-of-the-art NLP OIE methods: ClausIE, MinIE, and Standford Core NLP OIE. There are other OIE methods that will be evaluated and explored. For example, there's graphene and reverb, and also exemplar. And lastly, there was not a process where we evaluated the performance of these methods. So instead, we just aggregated the results, which may explain some erroneous results for some of the entities. And so in a previous study that myself and my colleagues have done, we introduced like a criterion to evaluate the quality of open information extraction. Basically an instrument to help assess like some of the extracted results. And therefore, we also need to assess some of the OIE methods before using it as a downstream application for ontology enrichment. So there's been some researchers that have explored the use of OIE for like, for scientific literature. And, while it's, potentially useful, there is a need for, reviewing kind of the quality of the results, as the results between, say, using consumer literature and scientific literature tend to be kind of different. So overall, we envision our next step is to first review the available OIE methods to determine the best performing method to utilize instead of using just an aggregation of all the extracted output. And as I mentioned before, in a previous study, we developed a criterion that can be used to evaluate the OIE methods for this stage. And with the best performing OIE methods, we will perform the extraction on a larger corpus of vaccine-related PubMed text. And using extracted entities, we will also work with potential collaborators in aligning the extracted entities and relations to expand the VO. And finally, we will systemize our approach in using OIE with the intention of making our work replicable for other open source ontologies. So we explored the use and possible utility of open information extraction to enrich open source biomedical ontologies, such as the one found in the OBO Foundry. For our test case, we experimented with the vaccine ontology and used a corpus of PubMed central abstracts from June 2023. And using 3 state-of-the-art open information extraction approaches, we derived a set of triples from a sample of vaccine-related abstracts. And while this work is early, we did find probable entities and relations extracted through these methods that might be used to enrich the vaccine ontology. And our future work will entail reviewing the accuracy available amongst the available OIE methods and utilizing a larger corpus of vaccine-related PubMed text to utilize for expanding the vocabulary of VO. So I want to acknowledge some of my collaborators, and also we want to thank the American taxpayers for the study. And that brings me to the end of my presentation.
Great. Thanks, Tuan. All right. Do we have any questions for Tuan?
Yeah.
Okay. Dr. Morgan first. Dr. Morgan, yeah, you can go ahead and ask a question.
Oh, Who, me?
No, Oliver, you can go first then.
Okay. So yeah, Tuan, thank you very much. It's a wonderful talk, actually. I feel quite excited about the method you are developing. So first of all, such a method is heavy needed, right? So we have a lot of ontologies, like OpenFoundry has, I think now more than 200 now. So we do need to expand and enrich, and currently AI tools actually are being developed, and those actually can help ontology development. Meanwhile, of course, ontology can help the AI as well. So it should be kind of bi-directional, right? Both ways. But currently, we focus on only application of ontology. So how to use virtual mining for ontology development actually is quite exciting and new, and people develop methods. But still, I feel like it's not much done actually, not much exciting tools available. So the method you are developing seems quite good. Because me as more like a vaccine ontology developer, I feel like the terms you listed, right? The new candidate terms you listed, actually they are pretty good fit for vaccine ontologies. So I'm happy to work with you and include I think at least most of the terms you provided to vaccine ontology. And meanwhile, I would like to happy to work with you. Yeah, you should have been working together a long time ago. But anyway, we can work now to start with from this one. I'm happy to be the domain expert. Yeah, to understand this one. Thank you. Yeah.
Right. I'll contact you like offline as well about our work. Okay.
Okay, may I ask my questions?
Yes, please go ahead.
Okay, thank you very much for the presentation, Tuan. It was very interesting. I was really, I was thinking that we could use such tools in our work. So we'll talk about it later, maybe. I have two little questions. First of all, you showed an example with the relations that you may extract from text, and you mentioned human papillomavirus, which is well, you indicated the is relation with HPV. So would you qualify it as same as or as a is a relationship? I would have imagined same as or something like that.
Yeah. So I guess so while it does extract triples, I mean, I guess the ISA would probably be like kind of a similar. I'm trying to think of the annotation, maybe like an alternative label, I guess.
Same as or
yeah.
Oh, yeah.
But
Okay.
I guess, but different OIE methods might treat that example differently compared to like say like ClausIE or maybe Standford OIE.
Okay.
So yeah.
So there might be a configuration or something to indicate which relation should become which one in the ontology.
Yeah, I mean, so for ClausIE, we didn't we just used default, and I know that in the past when I've used ClausIE, it does produce different results. So it's so I think I mentioned in my presentation that one of the things that we need to do is review some of the results a bit further and be able to select the proper configuration for our purpose.
Okay. And well, maybe my second question is related to that, because I was wondering if in the results you obtained, I imagine that you made a comparison between the three methods you used, and and I'm not sure I heard that. So did you find many overlapping triples?
Yeah, there are a few overlaps. I mean, we haven't, like I mentioned, we haven't investigated all the results in detail, but we did notice like some overlap with some of them. So and of course we also noticed like erroneous results which is another thing that we have to also investigate. So that's kind of like a step that we plan on doing like pretty soon. And so we need to, review the results and also incorporate some of the available OIE methods that we haven't tested as well.
Okay. Well, thank you very much for your answers and for the work.
Thank you.
Great. Do we have any more questions for Dr. Amith? Otherwise, let's thank the speaker for an excellent presentation.